as cloud computing goes mainstream, as you know, IBM recently announced a set of initiatives to make that happen, it's going to impact business, government, and have the kind of social impacts that you're talking about. It seems like it's great, but what are some of the challenges, so that way we can also look at maybe even the research issues, since a lot of the people at the conference are research.
First of all, an organization that wants to introduce cloud computing, the initial challenge is taking a business-driven approach, establishing a strategy, establishing an architectural concept, establishing governance. That's the challenge that we've had with large project, transformational projects in many different situations. The biggest challenge that I hear from my clients, from CIOs, CTOs, business leaders is, can I trust the delivery? Can I trust the security? If I move to a certain cloud infrastructure, will I be locked in? So the questions that we have here are, again, questions that directly relate to acceptance of a certain way of conducting business. You remember the so-called trust chasm that we had in the early days of the Internet, when the Internet actually became a medium for conducting electronic business. And the other challenge is, how do I do the right selection? How do I make the right selection between what should move to the cloud and what should not move to the cloud? There is no silver bullet. I would rather look at applications, workloads that can more easily be standardized. Those may lend themselves much more easily to cloud computing. Some collaboration workloads seem to be very high on many CIOs' lists. There are also good candidates around high-performance computing, especially where you've already introduced grid structures. That would lend itself to cloud computing. And in general, what our clients are looking at is something they call non-differentiating workloads, meaning the workloads are important, but they do not really need, all the infrastructure, all the quality of service that necessarily drags costs, delivery costs, that your highly critical workloads need. That's what they are going after. And a great candidate, especially because, there's so much to do, there's so many low-hanging fruit, would have to be in the development and test environments. And last but not least, think about those workloads that are only enabled through highly flexible, massively scalable execution environments. Think, massive, high volume, but still reasonably low-cost analytics. Think about much of what we see coming up as, we at IBM call it smart applications. Think of the pattern where a large number of distributed devices is actually instrumented and sends many messages, creates many events, creates a lot of data that needs to be collected somewhere and analyzed very quickly to draw conclusions. I mean, you see these environments in surveillance, you see it in scheduling, you see it in anything that monitors a large number of devices. So those are categories of upcoming applications that I believe are very suitable for cloud computing.
From a perspective of a pure technology, I know you're a technologist at heart, what are some of those issues to make those applications easier? For instance, I know Google, when they created their own cloud, they came up with this new programming model called MapReduce that allows you to do a lot of batch processing on the back end. What are some of the new things that you see are needed, or is it just regular old distributed computing but on a massive scale?
Regular new distributed computing, much rather. In a former life, I actually taught operating systems and distributed system, and it's interesting to see how much of what we learned, say, 10, 15 years ago, still is applicable, but now at a very large scale and with commercial urgency. So management of very large distributed systems, autonomics, in these environments, highly distributed management, support for multi-tenant environments, security models. All of these are extremely important ongoing research topic. But perhaps the most exciting set of research topics I see around the emerging programming models and application patterns. You mentioned MapReduce, and clearly MapReduce is emerging as a very powerful paradigm for content-centric applications. Another important consideration is, the types of lightweight, loosely coupled applications where computation and data are essentially separate, stateless execution. I mentioned that already, and providing persistence or connectivity to a persistent store. What is the trade-off between optimal quality of service and scalability? When you read some of the papers recently about some of the large cloud deployments, you will find that people are advocating relaxation of the traditional asset criteria. What are then the considerations that fall on the developer, the programmer, and how can we make it easier for programmers to write good applications in that paradigm? I mentioned multi-tenancy. Another important pattern that we see coming up is basically transactional databases, data-driven, small computation on small data, but only feasible if you actually introduce multi-tenancy high up in the stack. And then, of course, the evolution of some of the programming models that are near and dear to our hearts. The Java programming model, the Java enterprise programming model. We in IBM, for instance, are investing quite heavily in WebSphere in this space. WebSphere that's been tailored to work well with hypervisors. WebSphere that can be sprayed out into many large collection of execution nodes. The workload balancing that goes with that, which necessarily has to be goal-based, and how do you pull it all together into a management of application life cycles, of service life cycles. So those are interesting and immediately relevant topics in terms of the paradigm of clouds being large collections of virtual machines, which at least seems to be a very, very popular perspective on clouds. The management of images, the management of life cycle of images, extremely important topic. I think what we will see is that some of the old questions and some of the old solutions acquire a new sense of urgency, and I find that very exciting. So, and I also believe that part of the success of cloud computing is really going to be around how well are the communities going to form around these problem sets. How well can we organize the exchange of ideas, of best practices, even of assets in this space. And to take up one of the topics that has interested OOPSLA for many years, patterns. What are the right patterns for deployment into clouds? And we have very strong ideas here, very strong views, but I think in the end it will be very important for the successful adoption of cloud computing along a wider range of application scenarios to establish a rich set of application deployment patterns. So, those are a couple of things that are near and dear to my heart, and on which the Cloud Computing Architecture Board that we established in IBM and the research team in IBM are working quite heavily.
Oh, this is excellent. So I guess I'll give you the last word. So any other parting thoughts for OOPSLA and the conference and the meaning of that conference to you or to IBM?
Well, OOPSLA has always been, or quickly been, more than just quote-unquote a conference on object-oriented programming. It has, at least in my mind, morphed really into a place, a space where people come together to address many of the important questions of programming, programmer productivity, security and reliability, large-scale systems, and this is really about large-scale systems. So I would hope that OOPSLA will generate a lot of very fruitful discussions amongst technologies that will bring the cloud agenda forward.